Good morning, everyone. Trying to get you through your Monday morning. Welcome back. Thank you for joining us. I'm Steve.
And I'm Scott.
Together, we are Backyard Musings, Apple Valley, People's Republic of California.
Yeah, and we are talking about space, technology and space today. So here
Yeah,
we
that's
go.
pretty crazy. You're going to learn some stuff here. Pretty crazy. Our solar system is home to 8 major planets. Okay, there's a discussion about 9 or 8, but 8 major planets and more than 400 known moons orbiting 6 of those planets.
Okay,
Crazy.
so you made the comment about 8 major planets. So that would be it used to be 9, and that's because Pluto doesn't get the respect that it needs, right? Or it
Right.
should get. Okay.
Right. And just as an aside, there's 2 asteroid belts, one in between Mars and Jupiter. Is that right? Or Jupiter and something somewhere in there. Right at Pluto is the second asteroid belt. So
Okay. Maybe they consider that a moon now.
I don't know. Webb just spotted a carbon. The Webb telescope just spotted a carbon-rich moon factory, is what they're calling it, 625 light years away. That is a long ways away. I don't know how they picked it up, revealing how moons like ours may have first taken shape. But how did all those moons come to exist? Scientists have proposed several ways they could have formed. In the case of the large moons, such as Jupiter's 4 Galilean satellites, which, if you haven't seen them, it is like jaw dropping the first time you see them through a telescope. It's just very cool. The leading idea is that they developed from a disk of dust and gas that surrounded the planet as it took shape. That process would have occurred over 4 billion years ago, leaving only faint traces of evidence today. Would you like to know more?
So NASA's James Webb Space Telescope has now captured the first direct look at material within a disk encircling a massive exoplanet more than 625 light years from Earth. This carbon-rich disk may serve as a kind of a workshop where moons take shape. Because moons are thought to outnumber planets across our galaxy, and some could even host life. That's kind of scary. Studying how they form is a key to understanding planetary systems as a whole.
Yeah, so Io, a moon of Jupiter, thought to maybe contain life under the ice. Ganymede, Titan, it's got the rivers and lakes on it. That's a moon, Saturn's moon. Crazy, isn't it? This is just, I
Yeah.
mean, it's, it's so fascinating. We just can't get out there. We can just see, and just probe. We need to get technology faster than light technology that allows us to travel those distances instantaneously.
Right.
Okay, NASA's James Webb Space Telescope has made the first direct measurements of the chemical makeup and physical conditions inside a possible moon forming disk surrounding a massive exoplanet. This carbon rich disk, found around the planet known as CT B, that's CTCHA b, about 625 light years from Earth, would be a birthplace for new moons, although none were detected in the current Webb observations. The findings were reported in the Astrophysical Journal letters on September 29, 2025.
The young star that CT B orbits is just 2 million years old and still gathering surrounding material.
Wow.
However, Webb's observations show that the disk encircling the planet is distinct from much larger disk feeding the central star. The planet and its star are separated by roughly 46 billion miles. That's incomprehensible.
Yeah, that's a long distance.
It is.
Watching how planets and moons form is essential to understanding how planetary systems evolve throughout the galaxy. Scientists believe moons may be far more common than planets, and some could even offer conditions suitable for life. And we've talked about that. Only now, with advanced observatories like Webb, are researchers beginning to directly observe these early stages of formation.
According to the research team, this discovery provides valuable clues about how both planets and moons take shape. Webb's detailed data offer a rare opportunity to compare these young systems to the early days of our own solar system more than 4 billion years ago. quote, we can see evidence of the disk around the companion, and we can study the chemistry for the first time. We're not just witnessing moon formation, we're also witnessing this planet's formation, said co-lead author Sierra Grant of the Carnegie, however you want to pronounce that, Institute for Science in Washington.
Quote, we're seeing what material is accreting to build the planet and moons, added main lead author Gabriel Cunho of the University of Zurich and a member of the National Center of Competence in Research Planets.
Infrared observations of CT-CHA b were made with Webb's MIRI, which is a mid-infrared instrument, using its medium resolution spectrograph. An initial look into Webb's archival data revealed signs of molecules within the circumplanetary disk, which motivated a deeper dive into the data. Because of the planet's faint signal is buried in the glare of the host star, the researchers had to disentangle the light of the star from the planet using high contrast methods.
Man, I can just see him like taking these different photos and piece them together. Say, yeah, is that a planet? Yeah. Well, if they're having difficulty locating the planet or finding it, identifying it, how are they looking at this accretion, disk that's forming into a moon? How are they doing that?
I don't know, but you mentioned that. I was just thinking about the way this spelled out and what you're trying to describe. When my dad worked for the Jet Propulsion Laboratory, which I think I mentioned before, and his place of employment was the Goldstone Tracking Station, which is northeast from Barstow, about 75 miles from here, near Fort Irwin. And they would my dad would bring home these photos that the different satellites would take, like Surveyor and some of the earlier satellites, when they would pass by a planet. And they were like squares. And then they would transform these squares onto a photo, almost like a pantograph. Is it not a pantograph? Panorama photo. But it would like a puzzle. There would be a piece up here, piece here, piece here, and they would all piece together where you could see it, but it was not like the photo or the picture you're looking at there. It would be small square, small square, small square. So maybe that's what they're talking about here with that data.
Pixelated, huh?
Yeah. Yeah. And will you call that pixelated? Yeah, that makes sense.
Okay, is it my turn or yours?
I don't know. Where do we leave off?
I think it's yours. We saw molecules.
We saw molecules, and this is a quote, at the location of the planet, and so we knew that there was stuff in there worth digging for and spending a year trying to tease out of the data. It really took a lot of perseverance, said Grant.
And they're trying to find tiny molecules 625 light years away. It's just mind-boggling. Ultimately, the team discovered 7 carbon-bearing molecules within the planet's disk, including acetylene. How do they know that? That's C2H2, and benzene, C6H6. This carbon-rich chemistry is in stark contrast to the chemistry seen in the disk around the host star, where the researchers found water but no carbon. The difference between the two disks offers evidence for their rapid chemical evolution over only 2 million years.
A circumplanetary disk has long been hypothesized as the birthplace of Jupiter's 4 major moons. These Galilean stars must have condensed out of such a flattened disk billions of years ago, as evidence in their co-planar orbits about Jupiter. The 2 outermost Galilean moons, Ganymede and Callisto, are 50% water ice, but they presumably have rocky cores, perhaps either of carbon or silicon.
See, Ganymede would be and Callisto would be perfect bases to have human settlements. Perfect. I mean, the gravity would be much, much less than Earth, but there's water there.
Right.
Okay. Quote, we want to learn more about how our solar system formed moons. This means that we need to look at other systems that are still under construction. We're trying to understand how it all works. Like Cunyo, how do these moons come to be? What are their ingredients? What physical processes are at place? I got hiccups. And over what timescales? Webb allows us to witness the drama of moon formation and investigate these questions observationally for the first time.
In the coming year, the team will use Webb to perform a comprehensive survey of similar objects to better understand the diversity of physical and chemical properties in the disks around young planets. This Webb telescope, you don't hear about it much, but it has changed the way that these guys are being able to look into deep space.
Yep.
Big time. So
Yep.
I hope this thing just continues to work and work and work, that it doesn't go haywire or burn out or whatever it could possibly do. But it's amazing.
We need to crack the code on faster than light travel. We need to crack that code.
Yeah.
So that we can get to these, 625 light years might take 2 weeks of travel faster than light,
Yeah.
We need to do
what do they call that speed in Star Wars? Hyperspeed, or is that hyperspeed?
Warp.
Is that
Oh no, hyperspace.
Yeah, hyperspace. Yeah, hyperspace.
In Star Trek, it's warp drive. Warp
Yes,
space.
yeah, that's right.
And then the Borg had trans warp.
Yeah. Yep, they need to work on that.
Yep. All right, folks. Thanks for joining us. We'll catch you in the afternoon.
Take care, everyone. Thank you.